These are our notes for review point slope formula. There should actually be a hyphen between that title. And I'm just going to go through when to use point slope form and 3 examples of how a test or a worksheet might expect you to use point slope form. Okay, so when to use point slope form is really, there's a hint in the name. So we call it point slope form because it's the form of a linear equation. It's the form of a linear equation that is easiest to use when a point and a slope are given. So let's see if we can write that. So that's it in a nutshell. If a problem gives you a point and a slope, you should be using point slope form. We saw yesterday that if the question is asking about specifically the y-intercept, then we saw that using slope intercept was the best way to go. But in the problems that I'm going to show you in a few minutes, point slope form is definitely the best way to go. And although this says that the form of a linear equation that's easiest to use when the question gives you a point and a slope, the thing about the slope is they might give you a specific slope, or they might give you information about your slope. And we'll see that today too. Okay, so let's try the first question. Write the equation of a line whose slope is -4 and who hits the point 7, -2. Write the equation. So our goal is to, when it says write the equation, our goal is y equals mx plus b, okay? And you always want to do problems like this. I mean, honestly, I approach math like this the same way all the time. I always say, what are they giving me and what am I trying to accomplish? So that's why I write down that my goal is y equals mx plus b. And then I go through the question and I show evidence of close reading and I box out stuff that's important to me. And as soon as I see those words, slope and point, because I have done my time and I've written down point slope form on an index card and I've memorized it over and over and over again, when I see the words point slope, I picture the formula y minus y sub 1 equals m times x minus x sub 1. And there's really not, other than looks, there is no difference between this formula and this formula. So think about that for a minute. Other than the looks, there is no difference between those two formulas. So what do I mean by that? What I mean is that both of these equations end up in the same, they end the same way. And you don't have to write this, but they end the same way. They result in the same information, okay? It's just a matter of, do I have slope and y-intercept, or do I have a slope and a point? Okay, and in this case, I have a slope and a point. All right, so I'm going to pick up the pace a little bit. So now, my substitution, I might go up to my question and remind myself slope is m, and point, I might remind myself that it's x comma y, because it would be silly to make a mistake in that part. So I just take out everything that I would need and lay it out in front of me, and then I start my substitution. Notice how my parentheses are only taking the spot that was the y sub 1. Okay? And only taking the position that was the m. I'm going to spread this one out a little bit. Okay. I know that looks like a mess, but if you're following along with me, hopefully you understand why there's all those parentheses. So I'm going to use a different color for my substitutions. So slope is -4. So I'm going to find m and replace it with -4. Okay. And my point is 7, -2. So that means my x is 7 and my y is -2. And I'm going to need to be on my toes for that one, because when I substitute -2, it's going to end up being y plus 2, because it's y minus -2 right now, and it's going to become y plus 2. So I keep working, taking it one step at a time. So on the left side of my work, I have y plus 2 because of those two signs. On the right side, I'm not ready to do any distributing yet. I'm just going to kind of rewrite it and clean it up a little. So I am going to rewrite this -4, but I'm going to take it out of the parentheses because it's not really necessary. I'm going to keep these parentheses because they are very important. And I'm going to look at this part right here. X minus 7, I can rewrite as just x minus 7. Okay, I'm just removing some of the parentheses. But when in doubt, just leave the parentheses there. Okay, so let's keep going. Now, I should notice I need to do the distributive. So do distributive property. So I'm going to distribute -4 into the x and -4 into the -7. So on the right side of my problem, I end up with -4x and positive 28. On the left side of my problem, I have y plus 2. And at this point, I want to compare these two formulas and say, what's going on in this problem? Well, y is by itself. And what do I notice over here? Y is not by itself. So that's how I know I'm not done yet. Okay? Keep going. So keep going. So I'm going to subtract 2 from both sides because my goal is to get my y alone. And I end up with y equals, right, because 2 minus 2 is 0. Y equals -4x plus 26. So that problem now should look the same. At least it should look the same format as my original goal. Okay. All right. Pause the video. I won't erase it, but I'm going to switch slides. Okay. Okay, so here's our next couple problems. Okay, I think that should be enough room. So take a minute now. This is still on page 111 in our notebook. You guys probably are able to write a lot neater than I am with my pen. So you should take a minute to look up what's true about two lines. What's true about the slopes of two lines that are parallel? Or you could say, what's true about the slopes of two parallel lines? Go ahead and pause the video and look that up. Okay. Hopefully, when you looked that up, you found that parallel lines have the same slope. So why am I bringing that up? Let's read the question. So example 2 says, write the equation of a line that hits -3, 9 and is parallel to the equation y equals -2x plus 11. All right. Notice how in example 1, I told you the slope straight out, but in example 2, they're telling you information about the slope. They haven't actually given you the slope. So example 2 is a classic Regents question, and they're expecting you to take this information and dig a little deeper to find your slope, okay? So if something is parallel to an equation, that means it has the same slope. Hopefully you found that when you typed it up on Google or something. Okay, parallel lines have the same slope. Okay, so that's the first thing we need to bring to this problem. The second thing we need to understand is they gave us a point again. Okay, so I am going to label it x, comma y, because it would be very frustrating to make a mistake like that. And I've made a little note that parallel should remind me of two equations that have the same slope. And now I'm going to turn my attention over to this equation, okay? And I'm going to think about y equals mx plus b, and I'm going to pull out what the m is equal to. And remember, m is slope, and that's what I need. So in this equation, the m is -2. And if I'm trying to write the equation, so I'm trying to write the equation of a line that hits this point and has the same slope as this equation, that means that I need this slope, m equals -2, and I need this point, okay? So now I'm ready to substitute. Y minus y sub 1 equals m times x minus x sub 1. And again, I'm going to set up my parentheses. And I'm going to substitute. So I've got my x and y are -3 for x. And my 9 is my y. So I'm going to come over here and write 9 into my y position, double check my substitutions, and then I'm going to jump over here and pull that m and substitute that into my m position. Now I'm ready to simplify. So I'm going to move a little faster. Y minus 9 equals -2 times x minus negative 3. But x minus negative 3 can be rewritten as x plus 3. And I would definitely recommend that you do that, because in a minute we're going to have to distribute. And with two signs, that would be a nightmare. So we're ready to distribute now. Negative 2 is going to distribute to x and to positive 3. And we're ready to rewrite. So we get y minus 9 again. And our distribution work is negative 2x minus 6. And we're almost there. Notice again, these are not quite the same yet, right? Actually, I didn't mean to point to that. Y equals mx plus b is not quite the same yet as where I am. So I need them to be the same. I need y to be alone. So I'm going to add 9 to both sides. Oops. And I get y equals negative 2x plus 3. And I'm done with that question. So pause the video and take a minute to write down the rest of that information, and I'm going to move on to example number 3. Okay? When you're ready, look up what's true about perpendicular lines. What is true about two lines that are perpendicular? So there's a couple ways that I could say this. I think when I was younger, I remember someone saying the negative reciprocal, right? I was curious what you'd find when you typed it in. So when I just pulled it up on my computer, I noticed it said opposite reciprocal. I like that one a lot. That's definitely a good one to go with. So the whole idea here is, again, just like example 2, write the equation of a line. So this, I'm reading example 3, but write the equation of a line that hits this point, negative 8 comma negative 1. So that's our x comma y. And is perpendicular. So that means we'll use the phrase that you'll find when you type it in, when you look it up. Opposite reciprocal slopes. Well, that's information that could definitely go on a flashcard. Remember, you don't need index cards to make flashcards. You could just take a piece of paper and rip it up into a bunch of 2-inch squares, and then you've got yourself some flashcards. So if we're looking at a line that is perpendicular to this equation, that means we need to pull the slope out of that. So remember, think about y equals mx plus b. We need to pull the slope out of this. So that means it's m equals 2/3 right now. But the perpendicular line to this would be the opposite. So that means negative. And then reciprocal, which means flip. So remember, reciprocal, refliprocal. So this is the slope that we're going to need to substitute. Okay? And this is the point that we're going to need to substitute. So we have y equals, let me try again. Y minus y sub 1 equals m times x minus x sub 1. So again, what do I have and what am I trying to end up with? So I'm trying to end up with y equals mx plus b. I have a point And now I've determined what my slope is, because they told me that the slope is perpendicular to the given line, to the given equation. Okay, here we go. So let's substitute with parentheses. Y minus, open parenthesis, equals m. Replace the m with parentheses. Open parenthesis, x minus parenthesis, close parenthesis. Okay, that's a mouthful. So what's my y? My y is -1. What's my m? My m is -3 halves. What's my x? My x is -8. So again, watch your signs. Take your time. I get, on the left side of this, I get y plus 1. Then I get -3 halves, open parenthesis, x. And again, now I have minus -8. So that becomes plus 8, close parenthesis. I'm in the clear now. Now I just need to distribute. So I'm going to distribute -3 halves times x, -3 halves times 8. Okay. So I still have y plus 1 equals, and -3 halves times x is -3 halves x. And -3 halves times 8, I'm just going to jump over to the side here. If I rewrite this, -3 halves times +8 just means -3 times 8, which is -24, divided by 2. Okay, -24 divided by 2. So what does that equal to? -12. Okay. All right. One more or two more step? One more step, really. Let's keep going. So we're going to subtract 1 from both sides because we need to get y alone. Subtract 1. And we end up with y equals -3 halves x minus 13. That is very small, so I can erase a little bit and rewrite it. But that is the work. So pause the video, write down what you can, and then I'll erase a little and rewrite the answer in case you can't see it. There, that's a little better. Okay, all right, we'll talk to you later. Bye.